Hi all. Today we are going to discuss about the motion of charged particle in a magnetic field. A charge Q is moving with a velocity v and it enters a uniform magnetic field V. Then the force experienced, it will get a force, and that force is magnetic force. That magnetic force is given by Fb is equal to Q into V cross B. We call this force as magnetic Lorentz force. So Fb is equal to Q into V cross B, or we can rewrite it as Q into A cross B is AB sin theta. In the same way, V cross B is equal to VB sin theta. And what is this theta? Theta is the angle between the direction of the velocity and the magnetic field. Here, in this section, we are going to discuss three different cases about the motion of charged particles in a magnetic field. The first case is the velocity of the charged particle is parallel to the magnetic field. So here as shown in figure, the field is uniform. You can see equal separation between the field lengths and the charge is moving parallel. That means in the same direction as that of the magnetic field. So if they are parallel, it means that the value of theta will be 0. Theta will be 0. So what happens in the equation of F is equal to QVB sin theta? This theta turns to 0, and you know sin 0 is 0. Sin 0 is 0. So what happens to this equation? F is equal to QVB into sin 0. Since sin 0 is 0, it will become QVB times 0 and force will be 0 in that case. So note that if the velocity of the charged particle V is parallel to the magnetic field, then the force, it doesn't get any force, the magnetic Lorentz force in that case will be 0. Now we are going to move on to the second case. If a charged particle enters a magnetic field at right angle to it, that means the direction between V and B is 90 degree. Then what happens is that it will get a force, and that force will cause that charged particle to move in a circular path. And the magnetic force that it gets during that time is acting as a centripetal force. You know, for moving in a circular path, we need centripetal force. So the centripetal force that is required for that purpose is supplied by the magnetic Lorentz force. What is the formula for centripetal force? We are denoting centripetal force as Fc, and we studied in lower grades equation for centripetal force is mv square by r. And I already told you that the centripetal force is provided by this magnetic Lorentz force. And what is the equation for magnetic Lorentz force? F is equal to QVB sin theta. And you know here theta is 90, sin 90 is 1. So the equation is QVB. And we know that this magnetic force is giving centripetal force, so we can equate them. Centripetal force is equal to magnetic force. Centripetal force is mv square by r, magnetic force is qvb. You can cancel out one v from both sides, so the equation will become qb is equal to mvr, and on rearranging v from here, bring this r to this side and multiply, and m to this side and divide. You will get v is equal to qbr by m. And this is the equation for the velocity of the charged particle when a charged particle enters a magnetic field at right angle to the magnetic field. Okay, and you can see that when the value of the magnetic field increases, the velocity also increases. Since both this is at the numerator, as v increases, v also increases. Okay, so we got the equation for the velocity of the charged particle when it enters at 90 degree. Now we are going to find out the equation for the radius. Since it is moving in the circular path has a radius. So radius, when rearranging from here, you will get r is equal to mv by qb. R is equal to mv by qb. And you can see that when the magnetic field increases, what happens to the radius? To find out to remind the radius of the circular path to be constant, what happens when the magnetic field increases, the velocity also increases to maintain the value of the radius of the circular path. Next is about the angular velocity. You know, v is equal to the relation connecting linear velocity and angular velocity is v is equal to r omega. Okay, so when you substitute the value of r from the previous equation, or when you substitute the value of v from the previous equation, v is equal to qbr by m is equal to r omega, and rearranging r and r can be cancelled from both sides, you will get omega is equal to qb by m. And you can see a term q by m here. This q by m is known as specific charge. Q by m is known as specific charge. So we got the value of omega, angular velocity, as qb by m. Once we have the value for omega, we can find out the time period of rotation, because you know the relation connecting time period and angular velocity is omega is equal to 2 pi by T. Omega is equal to 2 pi by T, or T is equal to 2 pi by omega. Substitute the value of omega from the previous section, which is QB by M. So you will get the equation of time period as 2 pi by QB into M. 2 pi by QB into M. Again, if you have time period, you can find out frequency. What is the relation between frequency and time period? Frequency and time period are inverse relation. Okay, f is equal to 1 by t. So for getting f, you have to take the reciprocal of this time period. That means it will be qb by 2 pi m. qb by 2 pi m, which is given here. Frequency is denoted by this letter nu also. So nu is equal to qb by 2 pi m. Next is about the kinetic energy of the rotating charge. Okay, what's the equation for kinetic energy? Kinetic energy is equal to half mv square, and we already got an equation for velocity as qbr by m from the previous section. So substitute the value of velocity as qbr by m. So when you take the square of it, it will be q square b square r square by m square. One m can be cut from the denominator and the top. So we will get q square b square r square by 2m, and that's the equation for the kinetic energy of a charge entering a magnetic field at right angle with the magnetic field. Okay.